Okay, before we get to the simulator, I wanted to spend a little bit of time with this little diagram just to explain that when an electron goes from the ground state to its first excited state, that means from orbital 1 to orbital 2, it requires a huge amount of energy. And so it's going to have to absorb a very energetic photon. In fact, that photon is going to have to be an ultraviolet photon, because ultraviolet is more energetic than, let's say, a visible photon because of the frequency. The frequency is higher for ultraviolet and therefore greater amount of energy. Remember that energy is proportional to frequency. And the types of photons that would cause electrons to jump up from the ground state to either the first excited state or the second excited state or the third excited state, those are all called Lyman series photons. And as you're going to see in the simulator, it's I think it's L alpha and L beta, the first one being L alpha, L beta, etc. These are all ultraviolet, very energetic types of photons. You'll also see the Bomber series. Those are they're designated with an H. It's H alpha, H beta, etc. Those are not quite as energetic. In fact, those are usually visible types of light. So if an electron, which is already in its first excited state, absorbs a visible photon of the right frequency, right amount of energy, it can then jump up to the second excited state, etc., etc. Those are what are called Bomber series photons. And then you'll also notice that any electron that goes from the second excited state to the third excited state, or from the second excited state to the fourth excited state, those are called Paschen photons, P-A-S-C-H-E-N. And you'll see these now down in the lower part of your simulator. The P's stand for Paschen, and again, the Paschens are in the infrared. They're less energetic because those are exciting electrons at higher energy levels. The Bombers are these H ones right here, and then the Lymans are down here. These are the very energetic ones. Notice that the energy increases. This energy increases from left to right, as does the frequency. The frequency increases from left to right. The wavelengths, notice, increase from right to left, because there's an inverse relationship between frequency and wavelength. The way this thing works is you start out with a hydrogen atom. There's the nucleus in red. There's your electron in the ground state, first energy level. And the question is, what needs to happen in order for that electron to be excited? Well, if you understand that previous diagram, remember that it takes a lot of energy to go from the ground state to the first excited state. It's going to require a Lyman photon. In fact, it needs the Lyman alpha. So if I fire a Lyman alpha at it, notice that yes, it gets excited. It doesn't stay there for very long. It turns out that electrons don't stay excited very long. They wind up giving off a photon of the same energy in a different direction and drop back to the ground state pretty quickly. But this little event log then shows what happened. We had excitation. The electron went from the first energy level to the second energy level. It required a 10.2 electron volt photon. That was an L alpha photon, and it gave off an L alpha photon. Notice I can shoot another type of photon, let's say an L gamma, at it, and now it excites it from the first energy level way out to the fourth energy level. It was a more energetic photon, and therefore it kicked it up higher in the energy levels, and then that electron became de-excited. Now I can fire, let's say let me fire an H beta, a Bomber series beta photon at it. And notice it does nothing. The photon just goes right by. The reason being it's not enough energy. It turns out that, again, this is the quantization. Electrons must be in these certain energy states. And if there's a photon that comes toward it that is not the right amount of energy, it's just not going to absorb it. And therefore the photon just goes flying right past. So that's the way this activity is done, is you're going to fire different types of photons at these electrons, causing them to be excited and de-excited. And you've got to figure out what happens when you fire these different types of photons. Keep a close eye on these different amounts of energy, the wavelengths and the frequencies involved with these photons, and that's how you're going to get through the rest of the activity. And that should give you some insight into doing the lab quiz properly.